Hello and welcome to this tutorial, getting started with Anssr Hadoop. My name's Tom, I am the CEO of Spicule Limited, and we want to be able to demonstrate to you today how simple it is to get up and running with a Hadoop stack using our Anssr data analytics platform. So just what is Anssr? As you can see on this slide, Anssr is a collection of open source tools that allows users to do more with data. What we are keen on doing at Spicule is empowering our users using open source software. So it's important to us to allow users to use the same software as they would do if they downloaded it manually, but by providing a more supported and organized platform around it. It's built upon Juju automation platform, which comes from Canonical, and we provide commercial support for many open source data related products. But the good thing about Anssr is we don't prescribe a specific format or way for you to deploy your software. We allow you to pick and choose what you want to deploy, how you want to deploy it, and also where you want to deploy it. So enough about Anssr. What is Anssr Hadoop? And so Anssr Hadoop is built upon Apache BigTop. Apache BigTop is the official Apache Software Foundation distribution of Hadoop. It's been tested, it's been battle hardened, and it's been packaged up ready for people to use. And so what we provide is a Hadoop distribution that's fully upstream compatible and is dependent on Apache BigTop, as opposed to a Cloudera or Hortonworks or a Mapr who will use their own variations, their own tweaks and bits and pieces that make their platform unique but make it less portable and less flexible. So Anssr Hadoop provides the building blocks for a scalable data processing framework. At its core is purely a Hadoop stack. But also on top of that, you can of course deploy Apache Spark, Apache Kafka. There's a whole range of inputs and outputs that you can tack on to both ends of the platform to allow you to do data science. Anssr Hadoop provides a fully working Hadoop stack on bare metal, on containers, or in the cloud, private or public. There's a whole range of deployment options. And so this isn't an Amazon EMR or a GCP, data processing pipeline. This gives you amazing flexibility in what you decide to choose as your deployment targets. You can deploy it to a bunch of servers as long as they're running Ubuntu, and it will behave just as nicely as if you deploy it into AWS or into Azure. You can pick your poison in terms of where it actually goes. So in this tutorial, what we want to be able to cover is streaming data. And so streaming data is, getting more and more leverage inside of businesses, and data streaming allows users to get faster access to insight because they get more real-time data points. It can provide reduced processing times by processing data more often. Instead of having tens and tens of gigabytes worth of data to batch process on a nightly basis, what you can do now is use streaming data to process data in a more frequent sort of manner, rather than queuing everything up till the end of the day and then processing it all at once. Data streaming allows users to connect together different applications that were at one point disparate and completely separate, had no idea how to communicate with one another. Streaming data allows you to create joins between these platforms so that they get more access to their data in a more frequent manner. The other obvious thing as well with streaming data is it can alert stakeholders to potential problems before they arise, rather than tackling issues in the business that could have been pointed out in the data after the data has been loaded. Many businesses still use month-end reports in terms of collecting and analyzing data. But if your issues with your business started at the start of the month, that might give you 30 days until you're aware of a potential problem that could have been pointed out in your data. So using streaming data and loading up data more frequently allows stakeholders to be more aware about what's going on in the business. So deploying into a cloud, I touched on it earlier. Anssr uses upstream packages from the vendor, so there isn't any lock-in, unlike using EMR, etc. You can deploy into a range of cloud providers using exactly the same packages. So when you decide to deploy Anssr into AWS or into GCE or onto bare metal, the packages and the distribution method are exactly the same. So you can be certain that what you're running will behave in the same way, irrespective of data platform. Similarly, if you decide to deploy it into an Openstack environment, private clouds are prevalent these days for businesses who want to retain the flexibility of the public cloud but keep it on their own hardware. You can easily run Anssr Hadoop and the Anssr platform on the private cloud stack. And also, as mentioned, you can use just a bunch of servers that are running Ubuntu Xenial or later, and they will be more than happy running the Anssr Hadoop platform. So, having taken all that into account and having had a brief look at what the Anssr Hadoop platform has to offer, we're now going to jump into a demo, and the demo is going to have a look at streaming data, how to stream data into the platform, how to process that data, but also how to run SQL analysis over it, how to gain insight into the data stream, but also the persisted data, and how to optimize and analyze that data in a more efficient manner. So let's head over to the demo. Then we're going to select the bundle from the list, and you can see here you get a nice README that explains what's going to be deployed, how to deploy it, how to get support for it, and that type of stuff, and what constitutes the bundle. Then we're going to add it to the model. So I've got existing models. If you're doing this from scratch, you'll add it to a new model. And then you can see it's put the charms, the applications onto the canvas itself. And there's also a nice getting started README that you can have pop up on the screen if you want some assistance in getting going. Once we're happy with that, actually what we're going to do first is just, by default it spins up 3 units. You can see here we've got 1 resource manager, 1 name node, and then we've got 3 workers. In this demo, we don't necessarily need 3, so what we're going to do is just chop out 2 of the units that we don't need just to save costs and spin up less infrastructure. And then we commit those changes. It will give you a summary of the charms that are going to be deployed. And then down at the bottom, we can hit the commit button. And now it will go to our cloud. In our case, it's going to be GCE, but this could be AWS or Azure. And you can see on the status page here, it's going to spin up the machines. And then once it's got the machines up and running, it's going to deploy the software to the machine. So this isn't container-based, so it's not Dockerized. So it will spin up bare Ubuntu units and then deploy the software to those units. And so it takes longer, but it provides more flexibility in terms of where you want to deploy it, how you want to deploy it, and all that type of stuff. So we're going to speed this video up because this will take about 20 minutes maybe. And so we're going to speed this up, and whilst it's doing that, I'm just going to explain what the Hadoop stack actually consists of. So you can see the machines coming up, and on there it's going to install Apache BigTop, and Apache BigTop is the official Hadoop distribution that comes from the Apache Software Foundation, who manage the Hadoop software platform. So Hadoop is completely open source and Apache license, which means that it's free for businesses to use, deploy, and utilize in business. But Hortonworks and Cloudera make a lot of money packaging their own stuff around it. But what BigTop is a community-led effort to test and deploy standard packages that they know work together. So in this demonstration, we're going to be spinning up Hadoop. So we've got all the Hadoop charms. We've got Flume that comes from there as well. We've got Kafka that all come from the BigTop repositories. And so when we spin them up together, we know they're going to play ball as opposed to picking disparate pieces of software, which makes people's lives easier to maintain, debug, and support. And so, what we're trying to do with Anssr is provide a stable platform. So it may not be bleeding edge, but it's not too bad. And, what it just allows you to do is just spin up software that is going to work. And so this is the Hadoop. There's another version coming. So by the time you see this, there's probably going to be a new version of Hadoop in the repositories. But yeah, this has been tried and tested and battle hardened. So you can still see in the status that it's installing the software. And then what's going to happen is once the software has been installed, it's then going to connect all those pieces of software together. So of course, in a deployment of applications, quite often different applications on different servers need to know about the location of other applications. So what Juju does is allow you to spin up all these pieces of software, and then Juju knows how to connect these pieces of software together so that they are aware of one another, so they set the configuration files appropriately. And irrespective of what cloud you do this in, or if you do this on containers locally, or if you do this in Openstack and private cloud, that type of stuff, it will do the same thing in each place. So it's not running different software because it starts from a base Ubuntu installation. It will deploy the same stuff across the board, and that barring gremlins in the networking layer, it will work exactly the same way. So you can see now that the Hadoop stack is nearly ready. So we've got 4 of the 5 units up and running. We're just waiting for the workers to start up, and then it will be complete. So there we go. You can just see the ports being set up, and then they're all ready. So then we know we've got a fully working Hadoop stack. So what we're going to do now we've got our Hadoop stack up and running, which is our data processing layer, data storage layer, I guess, for the archive. We're basically going to be using Hadoop for the HDFS layer. What we want to be able to do in this tutorial is be able to stream data into it. And so the way we're going to do it, again, is via using charms from the charm store. So you notice that we haven't actually used any command line stuff yet. We've got a fully working Hadoop stack, and we haven't touched the command line. And then what we're going to do is connect Flume. So there's a HDFS Flume, and then there's a Kafka Flume, and then we're going to connect it to Kafka. And we're going to deploy that in exactly the same way that we just deployed the Hadoop stack. So again, we've told it to start up some machines. Just get rid of that. We told it to start up some machines, and then we've now connected those units together. So it's going to go away, and it's going to start up 3 new machines. You could co-locate some of this stuff as well. It doesn't have to go onto unique machines. They can coexist with one another a lot of the time. But you can see those machines are now in the pending state. And so we'll speed this up again because it's just looking at the status screen a lot. But again, you're going to see Kafka come alive, Flume come to life, and then connect each other together. And then when those amber indicators go away, it means that the software should be up and running and available for users. So we'll just watch this run again. So you can see here it's waiting for a relation to the Hadoop plugin, that's for the Flume HDFS stuff, and similarly Kafka Flume is still installing its charm software, and then it's going to download the packages, install them, configure them appropriately. And you can see that 2 of the amber signs have disappeared, and then we're just waiting for Kafka. So Kafka, again, is going to download BigTop, it's going to install Kafka from its repositories. Oh, and we've forgotten our Zookeeper relation. So Kafka requires Zookeeper to maintain its configuration state. So we're going to stick a Zookeeper charm in there and then just fire that up. Zookeeper is the go-to configuration management engine for big software. And so Zookeeper, again, it's going to spin up a server and install BigTop base and then install Zookeeper over the top. So when that's done, Kafka will then come to life and we'll be good to go. So now everything's up and running, and you can see how we've got our 4 new charms that are attached to the Hadoop stack. So there's obviously some awareness going on the relations. You can't just relate random stuff. They have to support the relations so they know how to react. And then we're going to add our Kafka topic to the Flume charm, and under the hood that will go and update some stuff on the Flume units so it knows what it's got to configure. So let's take the go button now, go to that again. Then what we've got to do is set up a Kafka topic so that when we're streaming data in, Kafka knows what stream to pump the data down. And so if you look at the README file, there's a Juju run action which allows you to run a command or a script on the charm server itself. And so we're going to run an action that allows us to create a topic without actually having to SSH into the box. So you do have to use a command line at this point. Run actions do require use of the command line. Luckily, Juju GUI has a command line built into it, which makes life really simple. So we open up the command line. So this is still within the browser. This is all in the browser experience. And then we're going to create the topic for Kafka. And then you can see it returns an ID, and that means that the action has been queued. So it at least accepted it. It doesn't mean it actually runs successfully, but it means that it's accepted it. And then we can do Juju show action output, and then take that ID, and then put it in there. And we should see, there, so it's created the CPU metrics topic, which means that the command obviously ran okay on the Kafka box. So now we're going to actually create some data. This is about streaming data, so we're going to create some data. So I've got a script that, to make life easier, we're just going to run on the Kafka unit. So we've SSH'd into the Kafka unit, and then I'm just going to install Maven just to build the jar, but there's also the jar available pre-compiled if you want to use it. So we'll just install the software. Once that's built, the script itself is set up to write to that topic, so I'll just start it in a screen session, but we can do cd target and then jar for jar and then list of jar. And you can see it now just pumping records out into the Kafka stream. And so we'll shut that down because it will continue running in the screen session. And then we're going to just have a quick look at the HDFS server itself. And so these commands, they look sort of Unixy, but they're inside the HDFS cluster. So we can have a look inside Flume, Kafka, and then you can see there's a date stamp field. And from there, you can then see the text files itself that Flume is writing out. And so if we just cut that, you can see the data is being generated. And so we know that the streaming data is being written there. So next we're going to deploy Apache Drill. So we know we've got data flowing into the HDFS cluster. So next we want to be able to analyze that data, and Apache Drill is an amazing piece of software, again from the Apache Foundation and sort of shepherded by folk at MapR, a few other companies. And this is a great piece of software because what it allows you to do is run SQL over NoSQL data sources. The SQL could be run over S3, it could be run over HDFS, it can be run over traditional databases as well to do sort of data federation bits and pieces. But what it allows you to really do is run compliant SQL as well. And it's also a JDBC engine, so if you want to run queries via your favorite analytics engine, you can do so. But what we're going to do here is use it both to demonstrate querying over HDFS, but also we're going to use it for querying of Kafka stream. And so this is really cool. So you can tell Drill to run SQL, fully compliant SQL, over your Kafka stream. So you can see in real time what the stream is processing, what's coming into it. And if you wanted to do like real-time dashboard or something like that, you could easily build it out over the top of Apache Drill to demonstrate how that would all, to demonstrate what data is flowing through it. We're not going to do it in this tutorial, but the option is there for you to be able to build that type of thing out. And so We're just waiting for drill to come up. When drill installs, it also installs, because there's a relation to Hadoop, it will install the Hadoop dependencies and plugins and stuff. And so you can see just here, we're just waiting for the machine to come up. Once that is up and running, again, it'll install the software and configure itself appropriately. The other thing as well is that we haven't touched on yet is that drill is a web-based tool. So we get a nice web interface that we can expose and go and access. So you can give users access to this type of stuff by exposing the charm with Juju. If you're joining us late and you don't know what Juju is the automation platform that comes from Canonical. It was originally developed for Openstack deployments, but has been leveraged for other stuff now. So you can deploy big data stuff, you can deploy Openstack, of course, you can deploy Kubernetes, the canonical distribution of Kubernetes. It's a very flexible tool, and obviously you can build out your own tooling, your own charms around it as well. So if you want to contribute to the ecosystem or just do stuff for private, you can build your own charms that will allow you to deploy both into cloud and into bare metal services. It's not container based yet. That stuff's in the works, but it does allow you a great deal of flexibility in choosing your target and how you deploy it. So whilst that's installing, we will speed it up again. And once that's complete, we will then have a look at running some SQL over the top of that. So you can see in the status there, it's just installing Apache Drill, a couple of dependencies. Oop, that's that weird bug. Let me just refresh that. Once it's configured, we should be good to go. So let's just finish that off at high speed. Just wait for the Hadoop plugin to install. If you don't have Hadoop related, then it won't install the plugin. So that's also quite a nice feature about Juju, is the fact it only installs the stuff that it actually has to install. There we go. So once that's good to go, it might flip into an error state just as it's configuring itself, but it has sorted itself out. And then we've exposed the application, and then we can click on the link, and you can now see the Apache Drill GUI. So from here, you can do all sorts of stuff with Apache Drill. One of the cool things that the relations do is configure the data sources for you. So you can see here there's a Kafka data source. If I just click on that, you can see how it's set the IP for the Bootstrap servers automatically. So no user interaction required. If I go back, you can also see that's the Juju HDFS plugin. And again, that's set the DNS name of the server for you. So, you know, the relations do an awful lot of the heavy lifting, because then you don't have to remember some random JSON block. But if I do select star from Kafka.cpu metrics topic, and we'll just limit it to 10 rows, there we go. You can see how Drill has queried the Kafka service and then returned a tabular result set that has some Kafka information, but then also the data that I was streaming into the platform on the screen. So, you know, because it's SQL compliant, I could do a count, you can do group bys, you can limit, you can not limit, you can do anything that you think SQL should be able to support. You'll be able to run it over this stream, unlike some JDBC interfaces that can be questionable at best as to whether their support is of any good. So this is the web interface. You could run these same queries via Squirrel or, you know, Pentaho or MarkLogic or Seku or, you know, whatever. You can take your pick. And so what we're going to do is just demonstrate querying over HDFS. So I've added a Flume block here, which looks at that Flume directory that the Flume charm is writing to. And so what we've also done is then, because it's writing text files that really JSON, is in the JSON block, we've just selected, we've added a .text extension to it. So if I update that, so they were manual tweaks, but these are pretty minor. And then we do select star from Juju HDFS plugin, Flume, and then the directory name. And again, there you go. So the cool thing that Drill's done here is allow you to run SQL queries over a lot of files. If it's got files that are of the same structure in the same directory, you don't have to list a file. You can list a directory and it will concatenate them all together. Finally, what we're going to do is Drill allows you to read and write Parquet files. And Parquet files are column stored databases in a file. And so if we just write this one out here, they allow for greater speed. So if you've got tens of thousands or hundreds of thousands of text files, you don't necessarily want to be able to run an SQL query over them because it'd be slow. Parquet files like this one will allow you to create a column store database without having to deal with the actual file itself. So we've written it out. That one went to a real file. This one, next up, we will write that same file, but this time we're going to write it to Hadoop. So if I just demonstrate the file writing. So inside of the drill setup, you can define where it writes to. So in our case, that time it wrote to temp, and you can see a temp file in there. This time it's going to write to Hadoop, and so we're going to take that same Parquet file that's like hyper quick column store file structure for big data, and then we're going to write this one to the root block, which is /user/Ubuntu. And so if we do the same query, but this time just update the right directory. So it's like create table as structure, and this time we're going to write it to the Hadoop partition, and then we're just going to take that out. And then once again, we should be able to do a select star from, and there we go. So this time it's read from the Hadoop partition, and then we just demonstrate the proof that it's written from there, read to there, sorry. And if we look in user Ubuntu, you can see in there there's the Parquet distribution. So, Drill allows an awful lot of flexibility with regards to where you're going to read and write your data from and to, and with it being SQL compliant, it makes life very simple indeed. Helps to push the right buttons. There we have it. So hopefully you found the little introduction to Anssr Hadoop useful. You can see how you can quite easily build a very flexible, very powerful Hadoop stack with minimal command line interaction for a start, but you also get fully supported software, upgrades, all that type of stuff. But you can obviously plug in various bits and pieces that work for you, and it's not a fully, it's a bespoke package that makes the process useful for businesses who don't want to spin up 6,000 components to get their Hadoop product running. We sell and we offer the bits and pieces that we feel that will be useful, and of course you can extend it with your own as well. If you have Hadoop components that you want to be able to tie into your HDFS cluster or into your MapReduce engine or whatever it be, your Yarn bits and pieces, you can build charms to tack onto that as well, so you extend the model further and still leverage the same support that you would get otherwise. So there's a few questions that have sort of popped up over the last couple of days that have been asked of me, and so I figured that I would cover them off on this webinar. And so the first one, of course, is one that we hear quite often, which is what data is big data? And the term big data sort of riles me a bit in some cases, because of course a lot of businesses do have truly big data. They have petabytes of data or more, and they're processing it and trying to do analytics on it, and so that is big data. But the cool thing about Hadoop and Spark and all that type of stuff is that whilst you certainly need a degree of processing power, it's really there to allow you to process unstructured data, and that is, the crux of the matter. We are able to, the streaming data is a bit different because it's JSON, it does have a structure to it, it's got a document type. But Hadoop there is in general to process unstructured data, to be able to churn over a vast amount of it. But if you want to do text analytics, or if you want to do something that doesn't necessarily require 10,000 nodes, but actually processes unstructured data, then Hadoop can certainly help you in terms of distributing load, scale out, and that type of stuff as it does start to grow. So you've got to sort of think about the long game as well. And so, big data and unstructured data, their paths often cross. And so, be wary. But, for Hadoop stacks, it does make sense to have a reasonable amount of data. So, if you feel like you can cram it into a MySQL database and run your analytics on it, you probably can. But, if you want to scale up, or if you want to do something that's a bit sort of non-tabular and that type of thing, then sort of Hadoop can certainly help there. The other thing that I wanted to touch upon was a question that was put to me yesterday by one of our customers, which is, is Hadoop still relevant? With the Cloudera and Hortonworks merger, not enough potential there to grow two massive scale businesses side by side. And, I had this conversation with them, and what you find with Hadoop is, 5 years ago when it was all kicking off, everyone came diving in and figured that Hadoop was the best thing to ever hit the planet, and this was going to solve everyone's data processing problems. And of course, they have found that that isn't necessarily the case, and that, what Hadoop does well is solve some people's problems. And so, it's not like every business is going to go and spin up a Hadoop stack, but it doesn't mean that Hadoop is obsolete. It just means it's found its place in the market. And and Cloudera and Hortonworks have decided that to best tackle that, they will combine to then go target AWS and the cloud providers. But in terms of relevancy and what Hadoop can offer, still at its core is the Hadoop distributed file system that allows you to chuck data in it, make sure that it's redundant, and allow you to scale out horizontally as your data set grows. And that is a cool aspect of it. And of course there's Yarn for running applications, and there's still the whole ecosystem that allows you to tack on Apache Drill to do SQL analysis, or Kylin to do OLAP analysis, or Uzi to do workflow stuff. So just because it's matured enough for for companies to feel comfortable adopting it, doesn't mean that it's it's going to disappear anytime soon. And so Hadoop, I think, for a long time to come, will be the core of an awful lot of data processing platforms. It will evolve. It may be that various parts of Hadoop go their own separate ways and you're left with a more trimmed down model, but it is what it is. And I think that's where Hadoop will be, heading over the next couple of years. So, with Anssr, what we're trying to do is allow the platform to grow and develop alongside Hadoop, bring in the new platforms, bring in the new products. We're going down to Big Data London next week to demo Druid, Apache Druid, which has come from Netflix and a couple of other big corporations. But, that allows you to run analytics, real-time analytics over vast amounts of data that also leverages the power of Hadoop. So, these platforms are still relevant and will continue to be so. And so, I hope you join us on the journey. I hope that you try out Anssr Hadoop. It's free to try. Go to jujucharms.com and go and have a look and go and spin it up, and get interacting with the platform. And, give us feedback as well. Tell us what's missing. Tell us what you'd like to see, and also what we can do better to bring a better product to market. So feedback is crucial. So this isn't finished. It's just where we are now. And so let us know what we can do to improve the product, and we will certainly strive to do so.
So I hope you found this useful. I'll sign off now. Thank you very much for watching. Check back sort of in December, where we'll have another webinar about streaming analytics with the Druid stuff that we've been working on. So I hope you check back then, but bye for now.